We'll proceed in pseudo multivariate calculus. Long discussion that we are going through. Pseudo multivariate calculus, we'll proceed on this. Probably I'll start another series with different examples. We'll proceed on this. How to calculate surface area of a cone? That is a question. What is a cone? I had some paper. Okay, what is a cone? This is a cone. What is the surface area of this cone? This is a cone. What is the surface area of this cone? Now, we calculated surface area of a cylinder through cylindrical coordinate system. What is surface area of a cone? Okay, what is surface area of a cylinder? This is typically a cylinder. What is this curved surface area of a cylinder? What is the curved surface area of a cone? I'm not talking about the top surface area. What is the curved surface area of a cone? That is under question mark now. What is surface area of this cone? What is surface area? I'm not talking about top one. Only what is surface area of this cone? How we calculate it? Now I'll not talk about the modern way or conventional way. We'll talk about pseudo multivariate calculus. Pseudo multivariate calculus, that we are talking how to calculate surface area of a cone. Okay, now how to calculate surface area? That is a question mark. We will start by surface area of a cylinder, and then we will talk about surface area of a cone. Okay, we'll talk about the surface area of a cylinder, and then we will talk about surface area of a cone. What is surface area of a cylinder? Okay, then there is one cylinder out here. What is cylindrical coordinate system? If I talk about cylindrical coordinate system, what is cylindrical coordinate system? Cylindrical coordinate system is r cos theta I, r sin theta j, and zk. This is not cylindrical coordinate system that is mentioned in the book. Cylindrical coordinate, this is hybrid model. Means if this is a cylinder, then there is a circle here, and then there is a height here. Height is one coordinate, that is z, and circle, there will be a polar coordinate in the circle, where from the center there will be radius r, and radius will move 360 degree, making angle theta. In that sense, r cos theta I plus r sin theta j plus z height k is the Cartesian cylindrical coordinate system hybrid model. Anyway, someone is free to calculate the surface area vector of the cylindrical coordinate system. Okay, if I talk about the pure cylindrical coordinate system, then what is this point P here? If I take point P here, what is point P here? What are the three coordinates, three different independent three variables in cylindrical coordinate system? And those are z, that is height, radius, the bottom circle I was showing, their radius, and angle theta. If we see, then radius is length, height is length, where theta is angle. Anyway, what is the point P here? If I talk in Cartesian coordinate system, what is point P here? Then it is x comma y comma z. If I talk in hybrid Cartesian and cylindrical coordinate system, what is point P there? Then that point P is r cos theta comma r sin theta comma z. What is point P there in pure cylindrical coordinate system? In pure cylindrical coordinate system, one is r, one is z, and theta. Theta is angle. Theta I want in length. If this is the theta angle that rotates in 360 degree, then if I want length, then it will be the arc. This this part is making arc, circular arc. What is the length of this arc? R into theta. If I move theta angle, then radius into r. We are talking about this plane as this plane. Okay, in the cylinder, this plane. This is the height. This plane, it is moving theta. If I move theta angle, the arc it is making, that is r theta. Okay, any point P here, if I talk in a pure spherical coordinate system, any point P here, then that will be R, that is the radius, and then R theta, R theta, and Z, or R unit vector, plus R theta, theta unit vector, plus Z, K unit vector, that is the height. This is the pure cylindrical coordinate system, not mentioned in any of the book. Okay, you are great and you mentioned it. Thank you very much. Is it really useful? That is R into R unit vector plus R plus R theta into theta unit vector plus Z K unit vector. That I am saying this is cylindrical coordinate system, this is point P. Now, if I talk the surface area of this section, what is surface area of this section? That is under question mark. What is surface area of this section? To calculate the surface area of a curved surface, we will go by the flat surface. If this is flat surface, then surface area is width into length. This is pseudo multivariate calculus. Tackle any problem through simplest way. Simplest way is width into length is the surface area of this. Width into length, width into length. If this is origin, this point is xi, x1, y1, and this is origin and this point is x2, y2, then it is x1 whole square plus y1 whole square root, that is the width, and length is x2 whole square plus y2 whole square root is the length. Multiplication of these two is the flat area. X1 whole square plus x2 whole square root is nothing but magnitude of a vector, that is x1i plus x2 y1i, means magnitude of a vector, that is a vector, that is x1i plus y1j, and then magnitude of b vector, that is x2i plus y2j. Multiplication is the area, or I would say a vector cross b vector is the area vector, means x1i plus y1j cross product with x2i plus y2j, whatever comes, this is called area vector. If I have area vector, magnitude of area vector is the area. Otherwise, unit vector along this vector, cross product of these two, a vector and b vector, will give the area vector direction, and typically it is perpendicular to the surface. This is the area vector. Here, if this is the area, then area vector is perpendicular. If this is the area vector is perpendicular. This can be drawn by cross product of A and B. So, cross product of A and B is the area vector. What about the curved surface? Curved surface means our straight line A vector become a curved line, and straight line B vector become a curved line again. Okay, if that is the case, then again area vector. This is pseudo multivariate calculus. Nothing is going to change. We will enhance it, purify it, enrich it. Now the area vector is A cross B vector. Now A vector represents a curved line and B vector represents a curved line. What is the vector representation of a curved line? Okay, vector representation of a straight line is xi plus yj, where a straight line connects origin and point x comma y. If this is a straight line and this is origin and this is x comma y, the vector representation of a straight line is xi plus yj. If that is the case, then A vector cross B vector is the surface area of a curved surface, curved surface, where A vector is represent a curved line. How to represent a curved line through vector? We have demonstrated infinite time this, how to represent a curve, curve line. How to represent curve line? If this is the curve line, if this is the curve line, How to represent it in a vector form? If this is a curved line and this is x-axis, this is point x comma y and this is origin. If I talk about xi plus yj, that will be a straight line connecting origin and x comma y. But I want curved line represented through vector. In that sense, we see that for curved line, if this is x-axis, curved line everywhere y by x, y by x, y by x is different. In that sense, we have to represent our vector in terms of y by x because that is a variable. So if my vector is xi plus yj, if I take out x, then it becomes representation of a curved line. Or if I take out y, whatever it is. So I plus y by xj bracket close into x. This is representation, vector representation of a curved line. Or x by y I plus j bracket close into y. This is also representation of a curved line. Means if I want to represent a curved line, either I take out x or y, two independent components. Similarly, now what is the surface area of a curved surface? That is a vector and b vector cross product. A vector I can say I plus y by x j bracket close into x cross product with b vector, that is x by y I plus j into y. I take out y there, considering this is x axis and this is y axis parallel to them. Now, similarly, if I talk about the surface area of a cylinder, then what is the surface area? A vector cross b vector, where a vector in Cartesian coordinate is xi plus yj plus zk, and there b vector is also xi plus yj plus zk. In one place I take out x and other place I take out y. If I take out x, it becomes I plus y by xj plus z by xk into x. Now, division becomes differentiation. This is what we have talked. Division becomes differentiation and multiplication becomes integral calculus. In that fashion, the surface area of the curved surface in Cartesian coordinate system is I plus dy by dxj plus dz by dxk bracket close into dx cross product, because multiplication become integration into dx, y by x become dy by dx, z by x becomes dz by dx. That's it. Is it what calculus is? That's it. This is what calculus is. Division transformed into differentiation, and I plus y by x j plus z by x k whole multiplied with the x, it transformed into integral calculus, where x is independent component. If I multiply fx function over x and x, one is independent component and another is dependent component. If I multiply, it will become a integral calculus. If I divide fx function over x by x, where numerator is function over independent component and dependent, and denominator is independent component fx by x, it will become differentiation dfxy by dx, fx into x, fx into dx. Now similarly it becomes I plus dy by dxj plus dz by dxk bracket close into dx cross product with dx by dyi plus j plus dz by dyk bracket close into dy. Similarly, if I talk in the pure spherical coordinate system, then a vector is r unit vector plus r theta unit vector plus zk unit vector. B vector is again r unit vector, r theta unit vector plus z k unit vector. Now cross product of these two will give the surface area of this cylinder. Is it really true? Certainly. Someone can try. Now from one I'll take out one independent component. Now if I talk about the surface area of a cylinder, then r is constant, the base radius is constant, theta will vary 0 to 2 pi and z will vary 0 to height. In that sense, in one vector, multiplication of width vector and length vector is the area. Width vector is r unit vector in a spherical coordinate system. Width vector is r unit vector, and then r theta unit vector, because the r theta is the arc. We are talking position vector. Position vector in cylindrical coordinate system is r that connects origin and another point. Point must be in length. R is alright, Z is alright, theta is angle. So theta will transform to r theta, that is the arc. Now we have r unit vector plus r theta theta unit vector plus zk vector. Cross product with the same thing. Now one side I'll take out theta and one side I'll take out z because z is variable and theta is variable. Cross product. Will it really give the surface area certain? Try. This is pseudo multivariate calculus. Now if I take out r, it becomes r by, I take out theta, it becomes d r by theta. R by theta, r unit vector plus r theta by theta means r into theta unit vector plus z by theta k unit vector bracket close into d theta cross product, and that side I'll take out z r by z r by z r unit vector plus r theta by z theta unit vector plus z by z, that is 1 k unit vector bracket close into dz. This is the area vector. Okay, now division I'll change into differentiation and multiplication I'll change into integration. So it will become dr by d theta r unit vector plus r theta unit vector plus dz by d theta k unit vector bracket close into d theta cross product with dr by dz r unit vector plus r theta means r d theta, r is constant, r d theta by dz theta unit vector plus k unit vector bracket close into dz. Now dr by d theta is 0 because r is constant. If I talk about surface area of a cylinder, dr by d theta is 0. And next is r theta unit vector, that will remain r theta unit vector dz by d theta. Z does not vary with the theta. Okay, z is independent. So dz by d theta is 0. Now it becomes r theta unit vector. Cross product dz by dr by dz. Radius is constant. So dr by dz is 0. Now next is d. Next is r d theta by dz. Theta and z, they do not vary with each other. 0 and k. Only k will remain there. Now here r theta unit vector cross product with k. R theta unit vector cross product with k unit vector will come as r unit vector. Means area vector of a cylinder is r unit vector in radius direction. Can someone see? This is our proof. It is not available in any of the book. First of all, pure cylindrical coordinate system is not available in any of the book. Pure cylindrical coordinate system. People, they talk about the hybrid only, that is r cos theta I, r sin theta j, and zk. I, j, k are Cartesian coordinate system. They are not a spherical coordinate system. A spherical coordinate system must be in r theta k. If that is the scenario, then in a cylindrical coordinate, if I talk about the surface, if this is a cylinder, then surface vector is r unit vector. This is the base circle and this is the height. R means this is the center of the base unit circle. R is this radius from the center. R is this radius from the center. Means if I talk about the surface area, radius is, this is the radius vector all along from the center going outwards. So surface area vector, if this is the surface area vector is perpendicular to the surface. I have not taken top and bottom into the consideration. If I take the surface area vector will be parallel at every point in the top because they are perpendicular to the surface which is flat. This is surface area vector of the bottom. But if I talk about surface area vector of the curved surface, it is perpendicular everywhere. It is perpendicular everywhere because it is r unit vector. Now it is r into r unit vector because earlier it was r theta unit vector cross product with k unit vector. Theta unit vector, k unit vector cross product will come as r unit vector. dz d theta. R is constant, I can keep outside. Okay, dz integration of dz is z. 0 to height means height h. Theta is d theta integration is theta 0 to 2 pi. 0 to 2 pi means 2 pi. 2 pi r into height is the surface area. Up. Is it not true? Okay, okay, 2 pi r into height. I believe this is true. I have not checked. Okay, the surface area of a cylinder is 2 pi r. That is circumference 2 pi r into height. Looks correct. Surface area of a cylinder is 2 pi r into height. This is through pseudo multivariate calculus or length vector. Cross product of two length vector gives the area vector. Okay, understood. You always take very simple example. Try now the surface area. You are trying, right? Okay, I was trying. That is true. What you want now? I want area. Surface area of a cone. Okay, tell me surface area of a cone. Tell me surface area of a cone. You were trying like surface area of a cylinder. That was very easy. I know. Okay, try surface area of a cone. What is your cone? This is my cone. Up. This is cone. What is this curved surface area of a cone? I'm not talking about the top surface area. I'm not talking about anywhere there is nothing here. Only the curved surface area of the cone. Cone is considered as a subset of cylinder only. Okay, cone follows cylindrical coordinate system. Okay, means if I drop this cone inside a cylinder, then it will conform it. Only some area will be out. What is the curved surface? I believe volume of a cone is if it drops in a cylinder, if this cone drops in a cylinder where it matches the height of the cylinder and this side will exactly map the surface of the cylinder, then volume of this is one third of the cylinder constant. Okay, means it follows cylindrical coordinate system. If it is following cylindrical coordinate system, what is the surface area of this cone? That is under question mark. Okay, you were boasting about the cross product of A vector and B vector, where A vector represent a curved line and B vector represent a curved line. You took out one where theta and you took out one z, considering both are independent variable and r is constant. Now in cone, all three are variable. If someone watches the cone, if someone is really watching the cone, I always think that I should get one cone, ready-made cone, but I never get cone. Okay, if this is the cone, consider this is origin. It is kept at the origin. If it is kept at the origin, okay, if it is kept at the origin, consider this is the xy plane. If it is kept at the origin, this cone is kept at the origin, then if I grow like this, if I grow in all direction, because surface area is growing in all direction. Now the theta is theta is independent component, it is variable because theta will make angle from 0 to 2 pi. Height is variable. Here the height is different if I move. Here the height is different. Height is varying if I move. Theta is varying. Radius is also varying if someone think about it. Here radius is 0. But as we go along, radius will increase. All three are variable. Can someone tackle this problem? This is under question mark now. What is the surface area where three components are varying? Radius, height, and theta. But in surface area, there should be only two variables, not three variables. We are not calculating volume, we are calculating surface area. Surface area is A vector cross B vector. That is the surface area. A vector is r unit vector plus r theta unit vector plus z k unit vector, and B vector is again r unit vector plus r theta unit vector plus z k unit vector. If I do cross product of these two vectors, it should give the area. I don't want third vector. because after all it is an area. But there are three independent components, three variables are there. R is varying, Z is varying, and theta is varying. If I am doing cross product of two sides of a surface, if I take a surface, then this is A vector and this is B vector. A vector, if I take the curved surface, then A vector represent a vector of a curved line, B vector represent a vector of a curved line. But if I take a surface area of a flat surface, that is pseudo multivariate. We will start with a simple thing. A vector is R. A vector, if this is origin, then this point is R comma R theta comma Z. If this is origin, then this point is R comma R theta comma Z. Someone can say R1, R1 theta 1 and Z1, and this side R2, R2 theta 2, Z2, whatever it is. Cross product of these two will give the surface area of a flat surface. That is R unit vector plus R theta theta unit vector plus Z k unit vector. Cross product with R unit vector, R theta theta unit vector plus Z k unit vector. Now, if I take out one independent variable from this position vector, then it will become a vector representation of a curved line. The way we saw xi plus yj plus zk, if I take out x, then there will be y by x terminology there. Y by x should be there to make it a curved line vector representation. Similarly, I have to take out one independent variable from here and there. Which one I should take out? R, theta and phi. If anyone is watching very closely, then R and Z, R, theta and Z, R and Z are related to each other. If someone watches the cone very carefully, okay, someone is watching the cone very carefully, then this is the cone. This is the cone. If this is the cone, at any, if I make cross section at any point, this is xy plane. If I make cross section at any point, then this is a circle. Everywhere there is a circle. There is a circle at height z. Z is variable. At that moment, z, if I make cross section on the xy plane, this is the circle. Or z here, if I make a cross section here, this is a circle. And this from here to here, this is the radius. And here to here, this is z. Z is varying. From here, z is small, 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 becoming bigger. Consider this has cone has at the end height is h, that is the end height, and at the end radius is a, or at the end of the cone, means at the end of the cone there is a big circle out here. End of the cone, this radius is a, small a, that is constant. At the end height is h, that is constant. But every moment if I take, if I cut it, then radius will be different, height will be different. But this z and r are related to each other. How they are related to each other? Z and r, they are related to each other in the sense that if I take any point here, then z by r, same as height by a, because angle is same. If this angle is phi, then tan phi equal to z by a. Similarly, if I make cut here, then z by r is variable, z by a. This z by r, z by r, z is variable, r is variable, equal to height by a. A is the end radius, A is the end radius, and this is end height. Height by A equal to Z by R. R equal to A by height into Z. Makes sense? Now we can tackle with two independent components. Let's take theta and Z as independent component again. If I take out theta here, then it becomes R by theta, R unit vector, plus R theta unit vector, theta theta gone, plus z by theta, k unit vector, into d theta. Cross product, I'll take out z there, r by z, r unit vector, plus r theta by z, theta unit vector, plus k unit vector, bracket close, into dz. This is area. This is priceless $1 trillion. area we are trying to get from the cone. This is not available in any of the book. Anyone can try. This is priceless pseudo multivariate calculus we are talking. Now dr by dz, first is dr by d theta. Radius does not vary with theta. Theta vary independently. Dr by d theta is 0. Next is r theta unit vector, that will remain. And then dz by d theta, k unit vector. Z does not vary with the theta, that is also 0. Now this will become r theta unit vector. Cross r theta unit vector d theta. Cross product with another one, dr by dz. Dr by dz. R and z have relationship. R equal to a by h into z. Dr by dz is a by h. A by h r unit vector plus r d theta by dz. D theta and dz, they do not vary with each other, 0, plus k unit vector dz. At the end it becomes r theta unit vector cross product with a by h r unit vector plus k unit vector d theta dz. Now someone can try. R into a by h, r unit vector, theta unit, r unit vector, this side, I'm sorry, theta unit vector, that side r unit vector. Theta and r cross product will become z unit vector. Now it will become a by h into r z unit vector plus now this side theta unit vector, that side z unit, k unit vector, that will become r unit vector. A by h r unit vector. Okay, now it becomes a by h into r z unit, a by h into r k unit vector, because theta and r will result into k unit vector, plus r unit vector. Theta and z will result r unit vector. This is the area vector. Mind blowing, amazing. A by height into r k unit vector plus r r into r unit vector, whole multiplied by d theta dz. This is the area vector of a cone. This is not available in any of the books, I guarantee on this. What is your surface area? Calculate the magnitude of this. Then it becomes a square h square r square plus a square h square square root d theta dz. I believe we will do in another session, or someone can try. There is nothing big deal here. A by a square by h square into r square. R is a square by h square z square. If someone understands this, then it becomes a to the power 4 by h to the power 4 into z square. That is the square into z square. I believe so. Plus a square by h square, a square by h square, something like that. Someone can try. Okay, someone can try, or I did a mistake, I don't know. Okay, the cross product, the first cross product was r theta unit vector. Cross product with a by h r unit vector plus k unit vector. If I do cross product, it becomes r a by h r z, a by h r z unit vector, because theta and r will become k unit vector plus r unit vector. If I calculate magnitude of this, then this square root, r will come out. Actually, r will come out. So r will come out. R comes out, and it will be a square root of a square plus height square plus 1 square d theta dz. If r comes out, r is nothing but a by h into z. A by h into z. That is the r. Square root of a square by h square plus 1. That will be a square plus h square by h square square root. A square, if I take the cone, if I take any cone, then A square and H square will be this curve length square. You see the curve length of the cone. If there is a cone, if there is a cone, then this is the curve length. This is height. And this top, this is A. This is full height. And this is curve length. That is also constant. So it becomes L by A square plus H square root by square root of H square. It becomes L by H. Now it becomes A by H into L by H, means A into L by H square. Z d theta dz. Integration of z is z square by 2. Now z is 0 to h square by 2. H by h square is already there. H square gone. It becomes a. It becomes a into L. It was a by h into L by h. A into L by h square. Z dz d theta. Now it becomes h. So it becomes altogether a into L by 2 d theta. Integration of d theta is theta 0 to 2 pi. 2 pi, 2, 2 gone. Pi a L. That is the surface area of a cone. Pi into L into a full-fledged radius at the top. I have not checked it. I believe it should be all right. Someone can try it. Pi a L. That is the surface area of cone. That we derived from pseudo multivariate calculus. That's why I say pseudo multivariate calculus. It has innumerous potential. This is our invention. It is not available in any of the book. This has innumerous potential. It can someone can do calculate any complex mathematics through that. What we did, we started with a simple area calculation of a flat surface, then curved surface. Then we took out independent variable to make it representation of a curved line vector, and then cross product, and it came out. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.